Hello, this time potential divider quiz level 3. They get a bit harder here. Right, what voltage must this unknown battery provide? Okay, we've got a 100 millivolt voltage at the top of our potential divider here, and then we know the resistor here, 1 meg 27, and the resistance here, 2 meg 26, and we don't know the unknown voltage there. But we do know that the voltage at this point here is 28 millivolts. Okay, so if we know that the voltage here is 28 millivolts, then we can work out the current, because we know the voltage across this resistor. It's just 72 millivolts, from 100 millivolts down to 28 millivolts, and we know the value of the resistor, so the current flowing in this potential divider must be 72 millivolts divided by 1 meg 27. If we know the current, then we must be able to work out the potential difference across this resistor here. That's just V equals IR, which in this case is 72 milli divided by 1 meg 27 multiplied by 2 meg 26. And that gives me the voltage. If I know the voltage from here to here, then I must be able to work out the voltage at this point here. It would be 28 millivolts minus the potential difference across this resistor, which is this one here, 72 milli divided by that times that. If I know the voltage there, then I must be able to work out what the voltage across this voltage source is. So let's have a go. The current is 72 milli divided by 1 meg 27. Therefore, the voltage across this 2 meg 2 resistor here would be the current, which is currently on the variable x, multiplied by 2 meg 26. That's the voltage from there to there. That means that the potential at this point here must be 28 millivolts minus this lot, which is, I could calculate that back in the X box, 28 millivolts minus Y. That's minus 100 millivolts, really? So that must be the voltage here. The voltage of the unknown battery, since it's this way round, would be plus 100 millivolts. Great. Right, another one. This time we have to work out the unknown resistance. Okay, same idea. We've got the voltage across this resistor, and we've got the value of this resistor, so we must be able to work out the current flowing through that resistor. And that would just be 194 micro divided by 1K 18. That's the current. If I know the current and I know the voltage across this resistor, which I do, because on this side here, that resistor is 900 microvolts, and on this side here, it's, well, that's minus 900 microvolts, and then plus 194 microvolts. So that would be minus 900 microvolts plus 194 microvolts. There's a total voltage across that resistor of 0.001606. So the resistor must be the voltage, which is currently in the Y box, divided by the current, which is currently in the X box. Great. I'll just do one more. What resistance must the unknown resistance have? Well, it's similar to one we've done before. That is minus 70 millivolts. That is minus 74.9 millivolts. So there can only be 4.9 millivolts across that resistor. And we know the value of the resistor, so 4.9 millivolts divided by 1 meg 69, that must be the current that's flowing. And since this is more negative than this, the current is flowing this way, left to right. We also know the voltage across this resistor, because it's minus 80 millivolts on this side and minus 74.9 millivolts on this side, which makes the voltage across that resistor 5.1 millivolts. And if we know the voltage across the resistor, 5.1 millivolts, and we know the current through the resistor, we just worked it out down here, it's in the X box, divided by X, we can work out the resistance, close enough to get it right. See if there are any other different types of ones I could have a quick go at. Oh, right, yes, this is worth doing. Using E12 values, set the resistor so the output is 0.872 times the input. Right. Point to note about potential dividers is that if you have a output which is a given factor of the input, in this case 0.872 times the input, then we can use the fact that the voltage drop across a resistor is proportional to the resistance, because the current through both of them is the same, to work out what the ratio of these two resistors must be. Well, the voltage drop across this one is 0.872A, and the voltage drop across this one is A minus 0.872A, which is 0.128A. So the ratio of the voltage drop, if I put this as V1, voltage drop across that resistor, and this V2, voltage drop across this resistor, then V1 over V2 is 0.128 divided by 0.872. And because it's the same current, I could write the voltage here as I times R1. Voltage 2 is I times R2. The two I's currents cancel, and the ratio of the two resistors must be the same as well. Right, what is that ratio? Well, 0.128 divided by 0.872 is 0.1469. So we need to find two E12 values which have that as the ratio in between them. And one way you could do that is just start with 1K and see if multiplying it by 0.146789 gets you anywhere near an E12 value. Well, it's very close to 150. Maybe that might be close enough. Let's give it a go. Yeah, good enough. If it wasn't, then the next thing I would have done was gone up to the next E12 value and see if there is an E12 value close to that one, and if not, the next E12 value. That's probably one that the quiz was expecting, because 220 is an E12 value. So if I set that to 1K5 and this to 220, then that would be closer to 0.872. I'll see if that is the answer it was expecting. Oh no, it's found a different one, 82 and 12, but the ratio would be the same. The ratio would be 0.146789. Right, I think that's all the different ones at level 3, or most of them anyway. Good luck.